Hello everyone, and welcome to our third webinar regarding the Atlas Open Call. And it's not only regarding the Open Call. We would like to present the Atlas properly to you, the entire project as well. Yes, and the agenda is the following today. So our coordinator Stefan Rieling will walk you through a short presentation regarding the Atlas, what we are doing there, why we are holding an open call, and yeah, so what are we expecting from the participants. And our experts from Agra Apps, Grigoris Magdakis and Petros Gasteratos. I'm sorry, guys, if I mispronounced your names. They are Atlas partners and will answer your questions, of course, all of our experts, but also will walk you through the special requirements for your applications. So then we will start, and please, Stefan, proceed.
Thank you, Tamara. Good afternoon also from my side. Thank you very much for joining and for your interest in our Atlas open calls. Yeah, my name is Stefan Rilling. I'm a researcher at Fraunhofer Institute for Intelligent Analysis and Information Systems. And as Tamara already said, I'm the coordinator of the Atlas project. And what I'm going to show you here is what we call the Atlas reference architecture. I would like to give you a first introduction about the technical foundation of the interoperability network we are developing in Atlas. As you might have already seen on the website and on our various social media sources, what we do in Atlas is all about interoperability, making agricultural digital software systems, agricultural machines, sensors, all the things involved within digital agriculture, making all these entities interoperable. And for you open call participants, most of you have such, or I suppose all of you have these digital solutions, and our main goal of these open calls is to include your solution into the Atlas interoperability network. And I'm going to present now how we envision that this is be done. So that's for sure something I do not have to tell you. Farming is complex, a lot of things to manage, a lot of work to do, a lot of different work. And there are already a lot of digital tools, software tools available, and they are used, especially on larger farms. We have quite a lot of work with the computer, with software systems. One example here is that's from one of our consortium partners, one farm, several sites, livestock, arable farming, 7 different software systems in use. And that for sure will increase in the future. And same holds true for machinery. Usually, especially in Europe, what we have is multi-vendor fleet operations. All of these machines, all of these implements from different manufacturers come with already a connection to the cloud, with portals you can log in. So it's already quite digitized. But the main pain point, so to say, begins when it comes to the exchange of data. And we see interoperability in digital agriculture mainly as the problem of how to exchange data between all these entities. how to make it happen that sensors can talk to agricultural machines, and all the data can be sent to a cloud-based software system and processed, and then the result could be sent to a robot, for example. So this is what we are dealing with in Atlas. What we want to create in Atlas, and what we are already working on since 18 months, is a standardized and extensible interfaces for data exchange, so that all these entities can, so to say, talk to each other. And what we have created so far, and what we have already implemented to a certain extent, is a reference architecture which specifies the basic interoperability building blocks. Here we have two basic concepts which complement each other. On the one hand, we have the data platform-based data exchange and processing. So that is that you have software systems in the cloud, you have user accounts for these, you have data on these systems to do processing, and you want to interconnect these systems. On the other hand, what you also need is computing capabilities at the edge of this network. So you need computing capabilities in the barn, you need it on the machine, you need it in the field. And therefore, we also are specifying a architecture which provides capabilities for onboard and on-site computing and processing capabilities. These two concepts complement each other, and the goal is to have here a standardized and solution which is open to use by everyone. As you see in the picture on the right, we have here several building blocks making this interoperability network. And actually, we have the network is a distributed one, so we do not have a lot of central components, but we have some central components. We have entities which we call a service registry, which is a trusted directory of participants and the services they offer. So this is what you can call a phone book, a telephone book, where you can look up participants, where you can look up services, and where you can look up information on how to connect to these services. Then we have not a central component, but a component you have to or you could use on the field, in the barn, on the machine, what we call app engine. The app engine is the edge computing platform, which I already introduced. And you can see that as a sort of a runtime environment where you could put apps on it, which do any form of calculations. Also, this app engine offers standardized interfaces to the interoperability network and to sensors. And all these app engines and the equipment where these app engines run on are then administrated by a central component we call equipment center, which offers a unified view of farmers' equipment, its capabilities, and which enables the communication between services, cloud-based services, and apps. So as I already said, services are the basic means to exchange data between systems. And services are provided by participants. Participants are verified legal entities which are part of the Atlas interoperability network. You can imagine this, for example, a farm management system provider that could be a participant which offers various services from the farm management system in the Atlas registry. Participants can therefore have a multitude of different users. So don't confuse participants with the end user. And then these services, they are the means to exchange data. And services offer a standardized interface, standardized API, and standardized data formats to exchange data. You may ask yourself, where does this standard come from? This standard is in the Atlas domain called service templates. So these service templates describe semantically related agricultural or technical functions and describe the API parameters and data formats, and services implement therefore specific service templates. And so the connection of different systems of different platforms is shown on the right as an example. So consider you have a farm management, you are a farmer, have a farm management information system, and you have a machinery where you have a cloud connection too. So you have user accounts on both systems. And then imagine the machinery platform offers a service which delivers you task data you have defined in the machinery platform, and you want to have that task data in your farm management information system. For example, if you want to see at which field what amount of yield was harvested. So you want to interconnect the farm management system with the machinery platform, and this is done using the dedicated task service. MIS implements a service client which could connect to the task service on behalf of the user and exchange data. To do this, that pairing mechanism with where the service registry is involved is used to make these services make the farm management system being able to talk to the service. So this also involves authentication mechanisms. We have to identify that the systems are somehow valid partners or valid participants, and that the user has accounts on both systems. And this is technically mainly solved by basic OAuth 2 authorization flows on various levels. This is what you see here, a more detailed view on that. So typically these participant software systems would involve some sort of an identity provider, consent management system, and do the administration of data. What is crucial here to understand is that there is no central platform where data is stored and accessed. So all the data belonging to a specific software system is stored at the specific software system. So the participants have their system already implemented, and they just need to implement this service interconnection mechanism to make systems interoperable. That basically describes what I've already said in more detail. You see here in the service registry how it looks like. You have a participant, participant B, offering two services. The color indicates that the type of service or the service implementing a specific template. And if you want to connect to that greenish service, you need to just implement a service consumer, a service client, and then invoke that service pairing flow. So this results in a service mesh network where each participant stays autonomous and each participant is responsible for implementing and providing services. And this allows to keep the central components to a minimum. And this allows also for end users that they could use the systems they are used to. They have good reasons to use existing systems, And what we want in Atlas is not replacing all existing systems with a central Atlas platform, but we want to make existing systems interoperable. As I already said, we also have foreseen a concept of on-board or on-site computing. The App Engine, you see here a visualization on that slide. Consider areas of application as in-field operations with little or no internet connectivity, or where you require a very low latency when processing sensor data, which then controls, for example, a sprayer or a harvesting machine. So you need the results in real-time conditions, and this therefore involves on-board computing or edge computing. And the App Engine is a runtime environment, offers APIs to sensors, where we standardize different sensor messages, which could then be used to acquire sensor data by a app. And we offer something we call TNI API, which enables the connection to the machinery's ISO bus and to read data from the machine, and also to send data to the machine. And this runtime environment also, as already said, offers a connection to the cloud-based platforms of that machine. This App Engine, can somehow see it as kind of an operating system, but like Android. So it runs on a computer, on an onboard computer. We have different type of apps foreseen, requiring different levels of certification when it comes to security. This is important. If you talk to a machine, you have different security considerations than if you just read data from an in-field sensor and displaying it on a terminal. Or each app usually comes with a cloud-based companion service, which then connects the edge to the cloud. So to summarize it, we have drafted or already specified already on a good level of detail a system architecture to enforce interoperability between different agricultural systems, data platform based and onboard computing or edge computing is foreseen here. We only have two central components, the service registry and the app center. The rest is completely decentralized. We have already started to implement specific parts of the architecture, implement specific services, implement the service registry and the user interface for the service registry. And we will continue to make this vision come to reality and to demonstrate all the things within large-scale pilot studies within the next 1.5 years. The project goes. So that's it. Thank you very much for the attention.
Thank you very much, Stefan, for the comprehensive information. I'm sure everyone who didn't know the Atlas before, so they knew a lot now. They know a lot now. So I don't see questions from the audience yet. While we are waiting, I would like to briefly walk you through our website. So you all know that we are holding open call right now, and we are looking for innovative solutions to join our Atlas. And here is the entire information that might be useful for you in order to start and complete your proposal and write a winning proposal, which is most important. So that's a dedicated web page on the Atlas website. So regarding open call, here you can find all possible information needed, the general information, what it is about, so who we are looking for, who is eligible, what is the funding. I'm sure you know that Atlas gives funding to the chosen companies through the open calls to develop your innovative solutions. Right, and here is the tutorial on how to apply. And if you press the button apply now, you will see this platform where you can register and start your application. That's pretty self-explanatory. Right, and what might be also very useful for you, the section where we answer all the most common questions that we receive from, I don't know if it's big enough to see. So then here you can find probably answers to your possible questions already, but still use the chance to ask your questions our experts today, so they are live today and they can answer your specific question in the most efficient way, let's say. Right, here you can meet the companies that won our first open call. These are the links, so you can connect, you can see there's websites and you can connect with them. Unfortunately, one of our winners that supposed to join our webinar today couldn't come and couldn't make it. It's the solution called Fixed Eye. You can also go there and see that might also help you to understand what kind of the solutions we are looking for. Right, our previous webinars, you can watch the recordings from the webinars this year as well. And the most important part, the challenges that we have this year. And here you, of course, see all the descriptions and requirements, what we expect from you, what you have to pay attention to. But I would like to ask Gregory to join now and to probably elaborate on the challenges, why we chose these challenges for the open call, what are the requirements, what the technologies should be there and should be used there, and so as well. Gregory, can you?
Yes, thank you very much, Tamara, and thank you, Stefan, for the very detailed presentation. I would like on my side also to welcome you all in this webinar. As you have seen, of course, while Tamara was surfing through the Atlas website, a lot of information with regards to the challenges and with regards to where you can place your idea is already there. So I will not enter into very much detail. I will only say this, that we attempted in this, as we did also in the first open call, to move on and say how we can assist with regards to interoperability, with regards to data, with regards to services, to the whole agriculture and agri-food industry. Of course, this means starting from the farm with the first two challenges, of course, wind and pest control and the irrigation challenge, moving within the assets tracking and fleet management through the third challenge. Of course, farm to fork, a very important topic that is being highlighted a lot lately. Livestock challenge number 5. I'm quite sure that any of your ideas could exceptionally fit in one of those 5 challenges. What I would like to highlight in all those is that for the 3 out of the 5 challenges, the weed pest control, the first challenge, the challenge number 2, irrigation, challenge number 5, livestock behavior analysis management, environmental impact. We are also expecting from your side to include one of the, let's say, of the 3 or 4 selected technologies, and which ones those shall be: edge computing, robotics, robotic operation system, or in-field sensors. Apologies. So starting from your idea, we are expecting your idea to fit one of those 5 challenges. We expect your idea and your proposition to be at least on a TRL 6, and TRL 6 means that it has been validated in an industrial environment. So you need to also to justify the maturity of your proposition. We expect for you to take advantage of one of those 4 technologies or solutions that I addressed earlier in the 3 out of the 5 challenges. And of course, we expect from you either to build on top of the pilots, partners, farmers, etc., that are already participating in the Atlas consortium, or of course, and you're invited to do so, to bring on board as, let's say, associated partner within your proposition, one pilot partner or one partner that you are working with. Consider that at the end of the day, your proposition, apart from the applicable side of things where you extend current, let's say, value or added value of your service or of your proposition, you need to tackle at the same time the challenges that Stefan described within his presentation. And I'm repeating those again. We are speaking about interoperability. We're speaking about pairing services and pairing systems. Because consider that we currently in the market, there is a large number of services, of products. All those are lacking at the bottom, at the start, at the same time thing. They cannot interconnect, they cannot work together, they cannot easily interconnect and exchange data. So within Atlas, we are focusing, yes, on top of 5 challenges. We are expecting for the 3 out of the 5 challenges to have let's say, to focusing around one of the 4 suggested technologies, but at the same time, we want to see that your proposition connects with the interoperability and the functionality level as expected within Atlas. Please make sure that you pick the challenge that fits to your proposal best, and I'm not sure what else I can provide. I'm here for any questions that you might have.
Great, thank you very much, Gregory. Yes, if you are not sure at which TRL level your solution is, you can click here and see the definition of all the levels. So and you can easily understand which of your solution, if your solution eligible or not. Right, perfect. So I don't see questions yet. So it seems like everything's so clear that we don't have them, or everything is that unclear that also no one has questions. But I don't believe in the latter.
Both
Let's
would be a
for the
surprise for me.
Yes.
Say again, Stefan?
Both would be a surprise for me.
Exactly, yeah. Gregory, you were saying?
I'm saying that let's hope for the first one, that everything is clear, that the majority of the attendees within this webinar, but also those attending in the previous ones, have already a very concrete idea on top of the details that we have provided. And I'm quite sure that Tamara and the rest of the partners, Asia and the rest of the partners within Atlas are here. We are only one email away to answer any questions either within the webinar or after the webinar for any clarifications that are needed.
Exactly. Yeah, exactly. Thank you. That's exactly my message to please don't hesitate, even if you think that your question is not relevant or too small or too large or whatever else. So just if you have a question, just send it to us. And unfortunately, we can't introduce to you one of the winners today. As I said, she couldn't make it, but at our next and the last webinar in 2 weeks, we will make sure that you have at least one of the winners to speak and to ask questions. But anyway, as I said, so you can you can check them up on the website and connect with them and chat and ask for their insights. They're very open and very helpful as well. So then I still don't see questions. Then let's say it's a good sign. Thank you very much, Stefan, Gregory, Petros, for your time. That was most valuable and most interesting today. So then that's it for today. Have a nice day, everyone.
Thank you very much.
Thank you, Tamara. Thank you, everyone. Good luck to the attendees that intend to apply.
Yes,
Exactly.
we are looking forward for a lot of proposals. So
Yes.
Exactly.
goodbye.
Thank you. Ciao.